Kári Stefánsson founded Decode Genetics in 1996 and pioneered the use of Iceland's extensive genealogical records and population data to identify genetic variants associated with disease. For GenomeWeb's 25th anniversary, reporter Forrest Ray spoke with him about the past and future of genomics.
The first and biggest, potentially vaguest question is just, what you see as the biggest advance in genomics or precision medicine, molecular diagnostics, those areas over the past 25 years.
Before the possibility of doing genome-wide association, most of the gene discoveries happen through candidate gene work. And basically, if you look at the discoveries that were made through the candidate gene approach, almost all of them were false discoveries. So the one dramatic event that increased our ability to figure out the germline genetics of human diversity, including human disease, was the ability to be able to scan the entire genome for variants that correlate with the disease. Another thing that also made a really big impact is when people switched from being focused on single diseases and started to do population genomics. Because one of the problems when we are solely focused on a disease is that your recruitment efforts are heavily influenced by your a priori ideas of that disease. But once you begin to look at an entire population, recruit irrespective of diagnosis, irrespective of health conditions, you get rid of that bias.
Do you have any major successes that you would point to that kind of stem from that shift towards more unbiased approach?
Basically, the discovery of a few thousand sequence variants that correlate with, thousands of phenotypes. But there is more to it than that, because the interaction of the genome with the environment contributes an awful lot to the common diseases of man. You can basically look at age or time as a funnel that captures environmental influences, and the older we get, the more opportunities does the environment have had to have an influence on us, mostly through the interaction with whatever our genome confers on us. So basically, what I believe is going to evade us in the next few years is probably the contribution to new knowledge about common diseases of man is probably going to come as much from looking, let's say, at the proteome, which is a good reflection of environmental influences, than from directly and only study the genetics.
Over that time, have there been anything that really stood out to you as a surprise?
The biggest surprise to me is how large contribution de novo mutations in the genome contribute to public health problems. 1 out of 10 children born are born with a de novo loss of function mutation in a gene. So this turns out to be a much bigger problem than we thought. And what is interesting is that these genes, many of them turn out to be totally different from the genes you discover with the usual genome-wide associations, indicating that they are genes that are less tolerant of variants than the genes that are classically associated with a particular disease. So what is that trying to tell us? It is trying to tell us that we are still being sort of modeled. We aren't the complete product. We are constantly generating new diversity in the sequence, and then the environment is selecting the ones positively that confer on us, a positive asset. The tragic thing is that our ability to continue to evolve, which is rooted in the de novo mutations, is an ability that a small part of the population pays a very high price for. it's going to be a challenge to face us going forward, because this is going to continue to happen. And all attempts to prevent the generation of de novo mutations would basically be a direct attempt to exterminate our kind, because these de novo mutations are necessary for us to continue to evolve.
Oh, that's really interesting. I mean, my next question was going to be about the greatest obstacles to research that have come up over that 25-year span, and it sounds like this kind of discovery of the role and importance of de novo mutations in population health and how to think about that, how to manage it might be one of them.
Yeah, no, that's the biggest obstacle is the ability to manage all of this data that are generated in a decent, acceptable manner. And one of the obstacles is to be able to convince people in general that knowledge is never evil. And therefore, when you discover something new about risk of disease, etc., even though the possibility exists that it could be exploited to the detriment of individuals, basically that is not in the nature of the discovery, but only in the nature of the way in which it is used. And I think that the sort of bioethical challenges have been significant. It has turned out to be fairly difficult to convince people in general that this quest for deeper understanding of human diversity and therefore deeper understanding of the biochemical mechanism of disease, that it is to our benefit. That sort of blends into your question about or your concern about the fact that almost all of the genetics that has been done up until now has been done on people of European descent, all right? And it isn't a problem of the way in which the genetics community behaves. It is a macroeconomic problem. It is the way in which we, the old colonial powers, are treating the third world, all right? And the solution to that problem is not likely to go through genetics. It has to go through changes in the way in which, economic benefits are being distributed over the world.
Where do you see the field of genomics and of population genetics maybe more narrowly kind of moving in the future, and what obstacles do you think we have to overcome to get there?
I think it is very likely that the next big step in human genetics is going to come through the use of the genetics in the delivery of healthcare. We need to be much more energetic in gathering large amounts of healthcare data to use them to train artificial intelligence models to do, systematic analysis of healthcare data on all individuals. As the data are gathered, they become extraordinarily useful in shedding light on the nature of our species, what makes us strong, what makes us healthy, what makes us get diseases. And the interesting thing about healthcare system that is run in this way is that a patient, a sick person, ceases to be the primary customer of the healthcare system. Most of the customers will be healthy, and the role of the healthcare system will be to help them to sustain health, even though, of course, they intervene when diseases appear. And I think that we are decades, past the point in time when we should leave it just in the hands of an individual without any assistance from systematic analysis of data.